Welcome everybody in AP Chemistry series. Today, complete part 3 of acid-base reactions and buffers of section 8.4. Today, we're going to complete the reactions between acid and bases, but at that point, we're going to use weak acid or base that reacts with a strong acid or base. So what makes the weak acid or base unique? Just keep in mind, if you have, for example, a weak acid, the weak acid will produce a conjugate base. And just keep in mind the conjugate base at that point, it will be a little bit strong to react with water. Okay, so at that point, since we have weak acid and their conjugate base that will react with water, we're going to go to the concept of equilibrium thing, if you just remember. On the other hand, if we have weak base, we have a conjugate acid. The conjugate acid reacts with water. We're still in equilibrium, and that's why we have to do some calculations that are related to the equilibrium process. Just keep in mind, I want to revise you with, for example, HCl. If it dissociates in water with H2O, it will produce Cl negative plus H3O. And at that point, since you have a strong acid, the strong acid or the strong base, they produce a very weak conjugates in which they do not react with water. You can say whatever the conjugate things that are produced from strong acid or base, they have no effect on the pH of the solution. So at that point, we just stop. We don't make further calculations about the equilibrium thing in strong acid and bases. So let's take an example. Let's start with a first case at which we have weak acid, okay, with strong base. How can I deal with this? How can I write the net ionic equation for this reaction, etc.? So we're going to start with a very weak acid that is called hypochlorous acid, HClO. It reacts with potassium hydroxide, which is a strong base. So as we can see, the reaction between acids and bases, the products are water and salt. Okay, since we have water for the H's, then the remaining thing is going to be KClO. So these are the salts. Now, we have a full equation. How can I write the ionic equation for this reaction? In other words, like, what's the importance of the ionic equation? It tells me the involved species and the reaction. So first of all of these are in aqueous form, by the way. Here, this is liquid and this is in aqueous form. So the first part, and here, look at the acid. It's weak acid, and that's why we did not split it up. H, just like do not split. Okay, so in the weak acid or weak base, we just keep them as they are. I have to put HClO plus KOH from the previous videos. It's a strong base. It's ionic compound. It's an aqueous solution. It dissociates fully in water. It gives K positive and OH negative. And as we learned before, water is a covalent compound. It doesn't dissociate. We just put it like this. All right, and KClO. Just keep in mind, KClO is a ionic compound. It's in aqueous solutions. I can split it from here. Then I have K positive and ClO negative. Now the next step is canceling out the identical species on both sides of the arrows. So we have to cancel out the K's, and we'll end up with HClO plus OH negative gives water in a liquid state plus ClO negative. So this is the ionic equation for this reaction. I'm done with my first part, which is writing the ionic equation. Now let's go, what are the given thing in here? So first of all, the question says that we're given amount of 35 milliliter of hypochlorous acid of 0.2 molar for hydroxide, we have 25 milliliters with 0.25 molar. Okay, so the first step, since we're adding two volumes to each other, we're going to use the vom thing. So the first thing that we have to do is just like creating a Pureful table to show you what happened before and after the dilution of this product. So first of all, we have the hypochlorous acid, we have HClO and KOH. Their initial volume was, for the acid, it was 35 milliliters. It was 25 milliliters for KOH. Their initial molarity was 0.2 for hypochlorous acid and 0.25 molar for the potassium hydroxide. If we're going to calculate the new molarity of hypochlorous acid, I have to say the initial volume was 35 milliliters. It's multiplied by the concentration, I mean the initial molarity, and they have a total volume of 35 milliliters plus 25 milliliters. It's 60 milliliters multiplied by the molarity, like after dilution. And we just divide it over 60, divide it over 60. Just keep in mind this is in milliliters. Don't forget the units, okay? And you will end up with a new molarity of 0.1167. And it's the same thing in here, like 0.1167. We're going to do the same procedure for potassium hydroxide, and it's equal to 0.1042. And this is good so far. All right, I'm going to do the same procedure that was done in the previous example. I have to write the net ionic equations for my reaction. We have H2O and ClO negative. And okay, I have to say how much of HClO we have. We have 0.1167, and for the OH we have 0.1042. You have to see which of these two species is the limiting reactant. We can see that this is for hydroxide, okay? So I can say I have to subtract the amounts from the lowest concentration, okay, in order to say like they're neutral, like they reacted with each other neutrally. Okay, and I have to say, okay, the product here is 0.0125. But guys, at that point, you have to look carefully at your question. In the previous video, we ended up only with one product, which was H2O only. But at that point, I have a new product, which is ClO negative. And the ClO negative is the conjugate base of the acid. So as long as you have an acid, I mean weak acid with its conjugate base, or the opposite, or the base with its conjugate acid, you have to turn your alert on. You have to think about the equilibrium thing. You have to think about the Ka and the Kb at that point. So since we have this process, since we are subtracting from here, from reactants, we have a conjugate thing on the other side. I have to say, okay, we neglect water, we don't care about it, but since we have a conjugate pair, then I have to say plus 0.1042. Okay, this is the extra step in here, okay? As long as you have a conjugate pair and the product, you have to add what you subtracted, okay? Now we have a new equation, but how can I write this equation? Just keep in mind, we wrote the first equation at that point, okay? And it was for acid-base reaction, like the net ionic equation. But since you have a conjugate thing, you have to make a new equation. Okay, so what is this equation? How can I write it? The new equation that you have to write is the dissociation equation. In other words, since we have the acid in our reactant, I mean the weak one, you have to start writing the weak acid. So the weak acid is HClO plus, what is the next equation? Since we have an acid, then you have to write the dissociation equation, okay, which means it's dissociating in water. You have to show me the reversible errors. Since HClO is an acid, then it has to produce H3O plus. Okay, and then since we're just removing hydrogen and add it to the water in here to produce H3O plus, the remaining species at that point is ClO negative, okay, which means it's the conjugate base. And now we got two equations. The first one was acid base, and the second one is the dissociation equation. This is the second part that you have to do it always. Okay, since we are given the concentrations of HClO, I have to put, this is the initial one, okay. Water, we don't care about it. H3O plus is 0 at initial time, like we have to use, by the way, the rice table, okay. And the ClO actually is given for us. You can see this is the concentration. It's given, it's not 0, just watch out at that point. So it's 1042. Then I have to subtract, I have to say minus x plus x plus x. And at that point, I have to say 0.0125 minus x. Here we have plus x, and here we have to say 0.042 plus x. And just keep in mind, since we don't have quadratic equations in AP exams, we just neglect this part here and this part. What's the target of this equation? I'm just going to calculate the pH after combining weak acid with strong base. What will happen to the pH? Okay, the Ka is equal to the concentration of H3O plus multiplied by the concentration of ClO negative, and you divide it over the concentration of HClO. Okay, the value of Ka, by the way, is given to us, and it's equal to 2.9 times 10 to the power negative 8. You can see this is a very weak acid. The value here is 2.9 times 10 to the power negative 8. The H3O plus is equal to x. I put x in here. The concentration of ClO negative, it's here, but we neglect the x as we said. It's 0.1042. And then you divide it over the concentration of 0.0125. We neglect the x as we said. And if you apply some math, if you make a cross multiplying, you will say 2.9 times 10 to the power negative 8 multiplied by 0.125 and equals to x multiplied by 0.1042. If we divide the two sides by 0.1042, the same thing here, then the value of x, I mean the H3O plus, is equal to 3.48 times 10 to the power negative 9. Okay, and if you want to calculate the pH for this example, for this solution, you have to say the pH is equal to negative log the concentration of H3O plus, and it equals to negative log of 3.48 times 10 to the power negative 9, and you'll end up with a pH of 8.46. And you just notice that this is a little bit basic solution. The question now, what if we have weak acid and a strong base, the same as the previous example, but their concentrations are equal? Let's just show you. Let's take the same one like HClO. It reacts with KOH, okay? And since we have acid-base reaction from the previous example, we have H2O plus KClO. And if we want to write the net ionic equation, as we said, we don't like to repeat the same steps. It's just like these steps are covered in the previous example. So we have to put OH negative. It gives water, H2O plus ClO negative. If we have equal concentrations in volumes for both acid and base, and my question is how to calculate their pHs. What's going to be the pH after combining the two solutions? If we have 0.25 molar of HClO and 0.25 molar of the hydroxide or the base. Since the amounts of acid and base are equal, we're going to do the same procedure. We're going to subtract 0.25 and negative 0.25. Remaining concentrations of acids and bases are just zero. So we have to say, okay, we just noticed that one of the products is a conjugate base of the acid. Then I have to say, okay, equilibrium mode is turned on. We have to alert your calculations to say, all right, since we're subtracting in here, we're going to add the same magnitude to the products. So you have to say 0.25, but at that point, it's a plus. Keep in mind the relationship between all of these species is 1 to 1, and that's why we did not multiply it by 2 or 3 or etc., like based on the factor. Now I have to say, okay, we don't have weak acid, we don't have hydroxide, but we have only ClO negative. But what about the ClO negative? What does it do? As we said, since it comes from a weak acid, then it has ability to dissociate, or it reacts with water. Okay, if it reacts with water, then I have to write another equation, which is, as we said, it's a dissociation equation. Okay, how can I write the dissociation equation for ClO? We don't have anything of acid in here. We don't have any concentration of OH. All of these are dead so far. Since the ClO negative here, it's not an acid, but it's a base. If we dissociate it with water, as we said, it's a base again, it will produce OH negative. If you just remember from the definition of the bases, they have ability to produce OH negative. And if it produces OH negative, it means that the water in here lost one hydrogen, and this hydrogen is donated to ClO negative. Or in other words, you can write the conjugate acid of the ClO negative, which is HClO. And just keep in mind the value of Ka for this reaction is equal to 2.9 times 10 to the power negative 8. Okay, the first step here, guys, is writing the initial concentration of ClO, which is 0.25. We're going to apply the Rice table, by the way. Okay. Okay, so at initial time, we didn't care about water. It's going to be 0 for both guys in here. And the change will be negative x plus x plus x. And at equilibrium is going to be 0.25 minus x plus x. And as we said before, we neglect this part here because, we don't need that much big equations to be applied in our exam. And now I need to calculate the pH of my solution. So based on that, we have a weak base with its conjugate acid and the OH. So we can notice that first of all, we can write the expression of Kb that equals to the concentration of OH negative multiplied by HClO divided by the concentration of ClO negative. But we just noticed that the value that was given to us is the K, it's not the Kb. So how can I calculate it? You have to keep in mind there's a beautiful relationship says the Kw is equal to multiplication of the Ka times Kb. So since the value of Kw, suppose that the temperature is 25 degrees Celsius, it's 1 times 10 to the power negative 14. The K is equal to 2.9 times 10 to the power negative 8 multiplied by the Kb. The Kb value at the end is equal to 3.4 times 10 to the power negative 7. And we can apply it in here. So the Kb is equal to 3.4 times 10 to the power negative 7. The concentration of OH, and these guys are represented in terms of x's. So I have to say x squared over the concentration of the ClO negative, which is 0.25. And if you apply some math, you will end up with a value of x equals to 2.915 times 10 to the power negative 4 molar. And just keep in mind, guys, the value of x represents the concentration of OH. And my target is to calculate the pH. So how can I do it? The pOH is equal to negative log the 2.915 times 10 to the power negative 4, and it equals to 3.53. Okay, if I need to calculate the pH, I have to say it's 14 minus the pOH, which is 3.53, and it's equal almost like 10.47. So this is how to calculate the pH of the solution at which they are equal.